Hey everyone, welcome back. It's James here, and today what we're going to be looking at is how you can comprehensively use Python with Google Sheets. The main point of the session is to get you feeling comfortable with authenticating with Google Sheets, how to read, write, update, manipulate, store data, and share that Google Sheet with others. In order to begin using Python with Google Sheets, we're going to install a couple of libraries first. The first one that we're going to install is the Google API Python client library. This comes bundled with lots of things like Google Cloud Storage, BigQuery, etc. We're going to be using this later on, but I thought we'd install it now anyway. So we can do that by just doing pip install --upgrade Google API Python client. You can type this either in your Jupyter notebook with an exclamation mark or in terminal. Then we're going to import Pandas, JSON, CSV, and the server's account key after we have that. The next thing that we're going to import is gSheets. This is a Python package that will allow us to easily do lots of data manipulation on top of the Google Sheets REST API. So to install that, we're going to do pip install Python gSheets. We can easily authenticate with gSheets by first, let's create a client variable and then do gSheets.authorize and use the service account file key, which is called, in my case, service account.json. Once we've done that, we've actually got an authenticated Python client that uses gSheets as a wrapper. Now, I think the important thing to note is let's just focus on first extracting the ID. So for example, here is a spreadsheet URL, and within here, you can see we have an ID. So let's just say we wanted to get this automatically, and I'm just going to print this out. We could, for example, split this on this. Let's do /d/, and then we end up with two parts of our list, which is fine. So we can just, for example, do test. And if we wanted to even split this even more, so we probably only want to look at the second one. So we can slice that. Again, I'll just briefly show. So you've got the gSheets, the protocol here, and you've got that specific ID that we're really interested in. And we could just do .split again, and we could just do edit. And hold on, let's get that, which is what we want. And then we want to extract this to get back to a string, and then we can split. And we can just do, I want to split on the edit, for example, and then I want to take the first one, and that would be an easy way, a very hacky but easy way for us to get the ID, if we wanted to get the ID automatically. Now, there's three ways that we can open a spreadsheet. I'm going to specifically focus on two of them. One uses the ID of the spreadsheet that we just got, and the other one uses a URL, and we've already got the sharing version of that. I would also recommend making sure that you have specifically shared the sheet like so, otherwise you cannot actually utilize this. So let's open it by the key first. So we're going to do client open by key, and then we can pass in the key that we got, which was ID. Okay, and you can see that this is working because of what we got back. So I got back the test Google Sheet up the top, and we're on Sheets. So we're on Sheets 1. Sheets 1, you can see there. Okay, so that works. Now let's see a different way of implementing this. So we can do client dot, and then this will be client dot open by URL. And the URL that we had was the spreadsheet URL, so we can put that in there as well. Okay, great. So these are two methods that you can utilize in order to connect to your Google Sheet. Once you've connected to a Google Sheet, the next thing that we're going to do is specifically pick a worksheet. Remember that Google Sheets have many worksheets, and you might specifically want to pick more than one. In this case, we're just going to use one. So we're going to use WKAS and then do sheet.worksheet by title. And the title of my sheet that I would like to target is sheet 1. And just check that. Sheets 1. After you've done this, you can print your WKS And you can see here, we're in the worksheet called sheet 1 at index 0. Let's look at how we can access how many rows and columns we have. So this is very simple, and you can just do WKS on your worksheet and just do cols. And you can do the same for rows. Now let's see how we can upload data. And I think this is really great because you can run a script day, hour, even by the minute or every half a minute. And it really gives you a lot of flexibility into pulling, wrangling, and cleaning data and automatically pushing it via Python. So let's first look at some of the data that I've collected previously. And if you have your own CSV, at this point you can follow along with your own CSV. That's absolutely fine. I'm going to be specifically using some hrefs data that we used in a previous module. And this is already accessible, and I'll leave this in here. So we have this data frame, and it has 1,000 rows by 11 columns. Now there's a really cool command that you can use, and a lot of these commands will be chaining onto either the worksheet or onto the sheet client that we've specifically authenticated with. So in this case, we're going to do WKS set data frame. And you literally pass in your data frame, and you put a start, and for this, we are going to utilize a 1-1 position, which basically means when we look, we'll be uploading into the first row and first column as the start. You can also set the index to false. So you can see in this data frame, we have these extra numbers, and maybe we don't want to copy those across. Copy index is set to false. Copy head is set to true. So let's do that to start with, and then let's see what happens. So we've now populated this data in Google Sheets. Pro tip, if you need to append rows rather than delete, you can use this formula. So it is literally exactly what we just did, except we're going to add extend true. And the extend true means that you will never overwrite data to your data frame in Google Sheets. You will literally just append more and more rows. This leads us on to a second problem though. If you have not enough rows and you keep appending, or you have not enough columns and you keep appending, then you will potentially hit a nasty error where it will go, oh my god, you have reached the row limit or you've reached the column limit. Generally, this isn't actually the case, and it's more so that you specifically don't have rows and columns to fill that new data. In the past, I've run into this issue, and I've made a if and else statement that caters for this. Basically, if we don't have enough rows in the Google Sheet, we add them, and if we don't have enough columns in the Google Sheet, we add them. Now, that's all great. What happens if we want to download our Google Sheets data? We can actually reference this directly in a variable called getAsDF. And again, you're going to reference the specific worksheet that you actually utilized when you loaded it. And now if we look at this, we've got exactly the same data frame that we pushed in just a minute ago. But let's also say that we want to get all the data back in a very Pythonic way rather than in a data frame. That's also fine. We can use something where we essentially just say get all values. And you can see here, we've also got back some strings. And the reason why is if we have a look, you'll see here we've got some additional columns, and I'm going to show you how to avoid these types of problems later on because I think it's really important. One way that we could specifically clean all of the rows and all of the columns is to remove any of the empty strings for every single row. This is a nested list comprehension, but I think I'm going to walk through this very quickly. So the first thing that we're going to do is we're going to look at if you look at the all values. Let's look at what the data is. So in the all values, we have this list of list-like structure, and we're therefore going to have to loop over not only every row, but every list which is a row. So let's start by doing a list comprehension on every row. So we're going to say for row in all values, and then let's just have a look at what we get back. So we get back the rows, right? Now, we want to loop over this row. So we're going to do a nested list comprehension, and we're going to say for item in row, and we're going to literally just do if item, and then we're going to put item here. Now what's going to happen is when we loop over this row, which gets assigned here, remember that there's still empty strings here, but now we're going to loop over the list that's actually inside of the list of lists. And when we loop over this, we're going to say if the item is truthy, and what that means is it not an empty string, then return it, else don't return it. So when we run this, you can see that all of the empty strings are now removed. Getting ranges is also really easy, and the way that we can get a range is by doing wks.range. And if you're familiar with Excel, you'll know that you use this type of format for your Excel. And then we're going to do return as matrix. You can see it hasn't specifically come back with the empty cells, and the reason why is because we've actually selected to never include those. So you'll see, for example, if I go to Z, we're going to now get those back. But yeah, this gives you the ability to easily select a range. Selecting a single row is very easy. You can literally do wks get row and pass in the row index. So if we pass in, for example, 1, you'll see that we get back the first index, which we've set as the headers. Now earlier we've solved the empty string problem by doing a nested list comprehension. However, we're going to solve this in a much easier way by just doing including tailing empty is equal to true. And what this does is this specific argument just basically says if there's any empty strings in, just get rid of them please. And you'll see that when we now print the headers as false, and now you can see we have successfully deleted these empty strings. If you'd like to extract a column, this is really cool, and you will reference the getCol command. wks.getCol will pull the first column. It's really slightly non-intuitive at first because you would think that colzil would be the first, given that Python indexes at 0. However, gSheets works where the first index is position 1, and this works on this applies to both rows and columns. You can also easily sort by a column by doing sort range, and then tell it where you'd like to sort a range based upon. So here I'm going to sort on the range A2 to L1001, and I'm going to use the 4th column to do my sort, and the order that I would like to have it come back in is descending. Now if we see here, we have got 4th column, which is 1, 2, 3, 4, which is volume. So let's just, for example, say, let's do ascending. Yeah, great. So you can see that's actually working now. And let's just change that back to descending. Unlike the getCol, which uses 1 as the first column, the base column index in our how to sort by a column starts at 0. So for example, here keyword is 0, country is 1, difficulty is 2, and this allows us to do an easy sort range. We can start by selecting A2 and ending our range that we're going to sort out by L1001 with the base column index. And now let's set this to, I'm going to set it to volume, which in this case is 0, 1, 2, 3. And after we've done a sort range on our worksheet, you can now see I've got the ascending order of volume. Now what's really interesting is if we set this to descending, you'll see that we've got nans at the top, and under the nans are, by the way, not a number. After the nans, we've got our largest numbers, but maybe we don't want nans. So I think a really good point is to actually decide, how do we clear this Google Sheet and how do we pre-process our data so that when we push it into Google Sheet, there are no nan values, there are no not missing, not a number values. So the way that we can do clear is by just doing worksheet.clear. Now if we view the Google Sheet, everything disappears. Formatting also disappears, so if you need to specifically apply formatting, you need to make sure that after you do wks.clear, you really do reapply that formatting via code. Let's take our data frame and we're going to drop all of the nan values in the search volume column. So we're going to do drop NA, and then we're going to subset all of the NAs that we'd like to drop on the column volume. Now we have no nan values in our column, and we're going to use in place equals true, which basically just means make sure that this exists after I've run this command on the data frame. Now let's use the command that we learned earlier to set the data frame. And we're going to do a start position with a tuple of 1, 1. Now we've populated the data, and you can see there are no nans inside the volume column. So we can easily now just use the same command that we had before. So I'm just going to get that, which is the sort range command. Perfect. So now we can easily sort our Google Sheet depending upon the range. Looping over every single row is very, very easy. And as you probably guessed it, you're going to use a for loop. For row in WKS, print row. Every row gets printed out as a list. So for example, if we do index 0, we can extract the first column. If we do number 1, we'll extract the second column plus the header. Updating part of your Google Sheet is a really easy way for you to allow it to integrate with other APIs or other Google Sheets. The problem is there's several approaches here. I'm going to explore them in more detail. The first one is the dot replace with a pattern. So for example, we can do something like I want to replace all the values that are nans in this worksheet, and I want a replacement with a 0. Now you can see here there are no nans in the sheet when we've completely replaced these with zeros. But this might not technically be what you're looking for. Maybe you're just specifically looking to update and replace specific values within a single column. So now let's introduce using a find and an update. What I've just done here is I've cleared the Google Sheet and I've re-imported the data with WKS set data frame. So we've got our nans back. Now we're going to do WKS.find. And when we use find, we're going to say I'm looking for nans. Search by regex is equal to false. Match case. So we're going to make it case insensitive. We're going to say match entire cell is equal to false and include formulas is equal to false. Then we're going to say I want to look between cols 3 and 6 for nans. Rows equals none and force fetch is equal to true. Now when we run this, you'll see it's going to find all those nans and it's just going to return them as cells. So we actually just get to see like there's a nan in this cell, there's a nan in that cell. And we can attach this to a variable. And this kind of allows us to scan the Google Sheet for specific values in specific columns. Now that we have all of these cells in a variable, we can do some operation on them. So for example, for cell in cells, now let's just print the cells to start with. Okay, great. So we have them all in a Python list. Now what we're going to do is we're going to recall the name of it. We're going to call cell.value is equal to other. And then we're going to do wks.updateValues cell list is equal to cells. What's going to happen when we do this is we've gone over every individual cell and we've said for this nan I want to make it into a value of other. And then what we're going to say here is for this worksheet update all the values in this cell list which is called cells. So after you run this you can now see that all the nan values are being transformed into other. But also notice that we've only done that on specific columns. The CPS column and this return rate column has still kept as nans. So utilizing the above method, wks.find, also with wks.updateValues, allows us to specifically target columns and specific rows and update those cells individually. Do you need to add extra columns? Absolutely no problem. All you're going to do is just do wks.addCols and then simply add the number of columns you'd like to add. I'm going to add 6 just to show you, and then let's go to the sheet. Okay, great, so we've got more cols, and you could even say something like this, wks.cols, and if we do add cols, notice how that number grows. So we can easily see how many cols we have, and also after we've added them. Something that you might want to do, and this goes beyond the scope of just Google Sheets, is get a specific lookup table for columns or headers. In this case, what I'm going to be showing you is how you can get column names with column index positions. So let's get the first row using wks.getRow, and then we'll do number 1, and we're going to include tailing empty equals true. And the reason why is, let's say for example we had some empty columns in the middle. So let's add some, for example, like this. You're going to save that as the headers. Now, in order to get the index positions, we can use something in Python called enumerate. So first, let's do a list, and let's do enumerate on the headers. And now we come back with a tuple object. Every single specific column header has been assigned a number. Notice also that we've got the missing, we still have the numbers for even missing columns in the middle of columns. Now we can assign this to enumerated headers. Now let's remove any of the enumerated headers that have an empty string inside of this list comprehension, similar to what we did before, where we used a true of not an empty string being a falsy value to eliminate those. Let's print this out first. So you can see 3 and 4, even though they're columns in the middle, are empty strings. We're going to remove these. So let's create our first list comprehension by doing for tuple object in enumerated headers. Now you can see here that we can actually index this as it's a tuple object for every list iteration. For example, if we do 0, we get the first index, and if we do 1, we get the second index. And this is what we want to avoid. So we can do something like if tuple object 1, which means that this must not be an empty string. If it was an empty string, it would be set to false, and therefore it wouldn't return. Another way of writing this would be is not equal to empty string. So let's also then change this back to a tuple object. Great. And you can see now that even though the columns in the middle have been excluded, we still have the correct numbers for our indexes. So we can now reassign this back to enumerated headers. And what's really interesting is because we have a tuple object per line in a list, we can simply use dict, and this will actually transform it into a dictionary. So let's make this into a lookup table. And lookup tables are really useful for specifically, as you guess it, looking things up. As well as this, we can reverse the order of this lookup table, and it's really easy to do this. All we're going to do is we're going to do a dictionary comprehension. So we're going to say for key value in lookup table dot items, and let's just see if you wanted to write the same dictionary, you would just do this, right? Now you could also do something where you swap the key and the value around, which is exactly what we want to do here, because we want to say when I have this keyword, what index is it? So we can call this lookup table reversed. For example, if we use lookup table reversed and we do country, we're now actually able to get the index position of that column, which is great. And this method applies to anything. We've done some simple enumeration, some simple cleaning, and then we've made a lookup table and then reversed it. Awesome. You can delete columns with the following syntax: wks.delete cols, the index position, and the number of columns that you'd like to delete following that index. So for example, if we were to delete cols 1 with a number is equal to 1, we have keyword and country and difficulty, and after applying this, we only have country and difficulty. So again, this has been activated on the first column, which is literally the first column for gSheets, and we've only removed one column. Now, we can also use the lookup table that we produced before, and we can get the keys of this, and we can make these keys into a list. and then we can say lookup keys list. Now let's find the maximum of this list, and we can do this using an inbuilt Python function called max. And then what we're going to do is we're going to say I want to add +1 to this, and that's 13. So we know that we've looked at our enumerated columns, and the maximum that we have is number 12, and we're going to add 1 so that we avoid deleting our column. So now what we can do is do something like this. When we're going to delete columns, we need to work out the optimal index position. By looking at all the enumerated columns we had earlier and taking the maximum of those and adding 1, we can start on the column after that, which means that we'll delete everything after all of our columns that we actually want to keep which have data in them. We can then look at the number of columns inside of the Google Sheet and minus this max column. After you run this generic function, you'll now see that all of the columns have been deleted. Inserting columns is very easy and follows the exact same syntax as deleting columns with wks.insertCols, the col index and the number of columns that you'd like to insert with the appropriate values. Let's also look at how we can update a single column. For example, let's say we wanted to update the CPS column. So what we're going to use is wks.updateCol, and we're going to pass in the index. And remember, we have previously worked out a lookup table. Now we can look for the CPS and we will add 1. This gives us our index. Now the values, I'm just going to create the exact same number of rows that we have, and then I'm going to times that by NA. Now I'm going to introduce a row offset, and a row offset basically means that we will start at a specific row rather than starting at row 0. We're going to do this because we might have column headers, especially at row 0 or row 1 in the case of gSheets. So let's set a row offset of 1. And now when we update this, you can see we have avoided updating the actual first row, and we have then added nans or NAs to the rest of the column. Just going to go through a quick pro tip. So if you need to create a list of a specific size, you can do something like this, 5 times this. And let's do an item of this. Now you can see here we've created 5 of this, and then it's actually created the list this size. This won't necessarily work if you're doing this, because you now have double the amount. But if you had to do something like I want a list and I want to have, we can do something like this where we can say the number of rows that we have is 1001, and I want to do some value in that, maybe a nan, for example, with numpy, which is not a number, and this will now give us a specifically sized list of that type. And you can say this like test is equal to this, and then if you do test, you now have your exact size list, and we can see that. We can adjust the column width by doing wks adjust column width, and then this is going to be the start, so which column we'd like to specifically start increasing the width on, and where we would like to stop. So let's do start of 1 and end of 3, and let's make the pixel size 300. Now if you visit, you'll see column 1, 2 and 3 have indeed had their column size increased on width. Now sometimes you might want to specifically select a single row. We can do this by just using wks.getRow, and if we do number 1, you can see we've got the data back. Let's do number 2 for example, and if we would like to include the empty strings, we can do include tailing empty is equal to true, and then we could do number 1. Now we've actually previously deleted all of our empty columns, hence why this parameter is not returning empty strings. Inserting multiple rows is very easy, and we can do something like this where we want to create some values times by test, and this is the number of columns that we have. we can insert a row like this. WKS insert rows, and then we're going to insert number 3 for the index of that, and the values is going to equal to values. Now if you go back to our Google Sheet, we scroll up to the top, we can indeed see we have inserted that at number 1, 2 and 3. Deleting rows is very easy. We can just do WKS delete rows, and we pass in the index that we'd like to delete and the number of rows after that index. So let's delete 10 rows after index 5. So we can see here we've got these specific values, and then we can clean that, and you can clearly see we've deleted some rows. Now there's some really cool things you can do with gSheets in terms of the formatting. So WKS frozen rows allows you to set frozen rows, and WKS frozen cols allows you to set your frozen cols. So if we apply both of these as variables, now we can go back to the sheet and you can indeed see that we have applied this as a frozen type of formatting. It's easy for us to bold cells as well, and the way that we can do that is by using something called a data range. And we can use a model cell to say like this: we want to get a cell called A1, and when we get this model cell, we're going to change it slightly, and then we're going to reference the whole data range against this new cell. So we're going to say I want to change the format of this to be bold, and then I'm going to do a data range, and I'm going to say from range A1 to K1 on this worksheet, which is WKS, I want to apply this format of the model cell. Format model cell. So when we run this, that's now applying that format. So let's have a look at what actually happened. So if we go from A1 to K1, and then we look, we can see these specific cells have been bolded. So what we're going to just talk about briefly is batching your API calls. Now batching is a really important thing that you can do, and the reason why that you need to batch your APIs is if you make too many API requests within a given period of time, Google will block your API requests. So it's really important to batch them. Now the way that we can do this in gSheets is by doing wks.unlink before a range of update values that you can see here, and then afterwards you're going to do wks.link. And then what will happen is essentially all of these update values, they won't specifically call the API. And then when we do wks.link, all of those previous single requests will be batched into one or subsequent requests, which will mean that you're less likely to hit API errors. You can easily share your Google Sheets with other users. The following syntax that we use for that is we will call the sheet, which we previously binded to a variable, and then we do .share, and then you pass in an email, for example, james.aphoenix@googlemail.com. You'll need to assign a role to this. So it could be a reader, or it could also be potentially another role, which gives them additional permissions. And as well as that, we are gonna, I'll just also show you some other roles. So you could also, for example, have a commenter as a role. So we're gonna say reader, and we're gonna say a type is equal to user. And then you can also add on an email message as well, like this. So that's how you share a Google Sheet. It's also possible to export your Google Sheet as a CSV file on your computer. Now, this is very easy, and you can do this with wks.export, the file format, and then the file name and the path. Now, before you do that, you're gonna need to have the Google Drive API turned on inside of your Google platform, Google Cloud project. So go back into that project and turn on the Google Drive API like I've suggested here. After you've done that and you have now the Google Sheets API and the Google Drive API live, you can do wks.export and then add a file name. And once you've done that, if I just show you briefly on my Finder, you can now see there is an additional CSV file that is saved from this export. Sometimes you might want to turn your Google Sheet into a REST API for your future product or service. This is really easy, and what we're going to do is chain two specific commands that will allow us to, one, download the values inside of a Google Sheet into a Pandas data frame, the second thing that we're going to do is then we're going to transform that into JSON. And then with that JSON, you could specifically use that as an API REST point for your product or service. So the way that we're going to do that is we're literally going to say, I want to get this worksheet, which we previously referred to, and then I'm going to do .get as df, and you'll see that this returns us that data frame. Now let's save this to df, and I'll do this in 2 steps so that we can see what's going on. And then with that, we can do 2 CSV, for example, would be 1 output, but in our case, we're going to do 2 JSON. And this allows us to download all of the values from that Google Sheet and then specifically pipe it into 2 JSON. And that 2 JSON format is JSON, and we could essentially reference that as an API endpoint. Similarly to what we did in the past, where we would use our service account.json file to authenticate with Google Sheets, we're going to now just take a brief look at the native Python Google Sheets REST API. Previously, we've been using gSheets, but I think it's also really good that we just touch on this so you can see how to specifically work just with Google's native documentation. So the first thing that we're going to do is import this Google API client and a build. And then we're going to open the service JSON file and we're going to load that information into a variable called info. After that, we're then going to build our credentials with service account.credentials from service account info with the info. Now this credentials here will allow us to authenticate in the exact same way that we did with gSheets, but we're going to do it with the native connection. So the first thing you need to do is you need to build your service. So let me just briefly show you above here. So you're going to do the build with discovery.build, and in our case, we can just do build because we've done from Google API.discovery import build. So we can literally just do build, and then we're going to build Google Sheets v4 credentials equals credentials. Now you'll notice that we also need the spreadsheet ID for number 2. Then we also have to create, as the third thing, is the request body. After we've created the request body, we basically are going to call the service .spreadsheets and then do the values and .batchClear, passing in the spreadsheet ID, the body which we defined earlier. Once this request has been essentially made, like that we've got constructed, we're going to do request.execute. And after we've done request.execute, it will execute the request. So let's have a look at a real life example with batchClear. We can open it with a service.account JSON key. We'll get the info. We will get the credentials for here. We will do Google Sheets API, and then we will build that with the credentials that we have here. And then we're going to get our spreadsheet API. So you're going to need to change your specific spreadsheet API at this point, and that will be the ID inside of the URL that you can find up top. Then what we're going to say is we're going to build this request, and we're going to say I'd like to clear the ranges between A1 to A1000. When we're building it, you can see here we start with the Google Sheets API that we defined previously. We're going to say we're going to call the spreadsheets function. We're going to get the values that we passed in, the values function, and then we're going to batch clear. And when we do batch clear, we pass in the spreadsheet ID, and we also pass in the body, which is the ranges that we decided to specifically delete. So when we run this, if we go back, we can now see we've deleted the A column as we previously defined. You can also retrieve a range of cells using the native Google Sheets API. So first create a Python list with the range of cells that you'd like to retrieve, then create a request using your Google API, do .spreadsheets, .values, .batchGet, which is different from batchClear and the previous one, batch update, and then pass in your spreadsheet ID and the ranges. And then when we do this, you'll see we can now look at the response, and we're going to have to slightly parse this, but that's fine. We want to get the value ranges, and then from here we want to get the values. We do 0 to get the dictionary, and then we do values. Great. So this is how you can extract your values. It's also possible for us to add data validation with a other function called batch update. I'm going to briefly touch on this, and the way that you do this is you create a request with a list, and then inside of here you have a dictionary with the set validation and the range and the sheet ID and the start row index, which is the row index you should start at. So this will start at the first sheet. this will start at the first row, the first column, column 1 actually, so that's the second column, and that'll be the second row, and this will end on the third column. And then you can pass in your condition. So in this case we've said we want a type 1 of list and then the values. So now let's execute this and see what happens. So you can see here we started at the second column and we ended at the third column. So we only applied it to this column. Now if we have a look here, we've now got our data validation set up. So it's also possible to add in data validation. Hopefully that gives you a great idea of how you can use Python with Google Sheets. Please feel free to like, comment, subscribe below, and yeah, check out the links in this video.